Do you need maths teacher, chemistry teacher, English teacher, Kiswahili teacher? Worry not, we are here. Welcome. Let us go through structure and bonding. But here I'm going to basically concentrate on bonding. So we want to find out what is a bond first. So the meaning of structure and bond. So let us see, what is a bond? The mutual force of attraction that holds particles together when atoms combine during a chemical reaction is what we call a bond. So a bond is a mutual force of attraction that holds particles together when atoms combine during a chemical reaction. So a mutual force that is holding particles together. Therefore, that is the definition of a bond. Like I said, I want to concentrate on the bonds. So there is what I've given here, that laying, this is supposed to be laying up the foundation of bonding. So for us to understand what are the types of bonds and how bonds occur, there are basic things that you must have in mind. So you should be able to identify and differentiate, very important, between metals and non-metals. So if you don't know that this is a metal, this is a non-metal, then it is going to be very difficult for you to know which bond is this, which bond is between the compound given. Therefore, that's why I prefer taking you through the periodic tables slightly, so that you can see, we can understand which element is a metal and which one is a non-metal. Therefore, let us look at the only thing you need to know is the electron configuration. Hydrogen is a non-metal. Helium is a gas. These are gases. These are group 8. They are gases. Argon, all of these are gases. We go to rhodium, is a metal. How do you know? When you write an electron configuration and the outermost energy levels, is that element gaining electrons or losing? So for example, for lithium, it will lose 1 electron, therefore it is a metal. Beryllium, it will lose 2 electrons to be stable, it is a metal. Boron will lose 3 electrons to be stable, it is a metal. Carbon is a metal or a non-metal, so that one, leave it alone. And silicon, you leave the group 4, you leave them alone first. Nitrogen, is it a gas or a solid, or is it a metal or a non-metal? Is nitrogen a metal or a non-metal? Let us look at the electron configuration. 2, 5. So what will happen during the chemical reaction, or when it wants to become stable? It will gain 3 electrons to have a stability of 2, 8. Therefore, an element which gains electrons is a non-metal. Take it like that. An element that gains electrons is a non-metal. Oxygen, look at oxygen, is a non-metal. So it is 2, 6. Therefore, it requires 2 electrons to be stable. It will regain. Fluorine is a non-metal. It will regain 1 electron. So that's how you know a metal and a non-metal. Once you have differentiated, once you know this is a metal and this is a non-metal, it is going to be very easy for us to tackle bonding. Other metals commonly used, not found in the first 20 elements, include but not limited to zinc, barium, lead, iron, silver. So these are other metals which we don't have, but you will find when somebody asks you, what is the bond between zinc chloride? Zinc chloride, what kind of bond is that? Zinc oxide, what bond is there? So that's what I have written here. We have some other non-metals which are not in the first 20 elements, but we use them, iodine and bromine. They are in group 7. So they are non-metals. Very good. So another thing we want to look at is the nature of the chemical bond. Atoms are made up of energy levels. That is another thing you need to understand, energy levels. So in an atom, let me take you through this atom. This is an atom. An atom is made up of two major regions, that is the nucleus and the outermost energy levels. These lines, these are called the outermost energy levels. So in the energy levels we have electrons, and in the nucleus we have the protons and the neutrons. Very correct. In the nucleus we have the protons and the neutrons, but in the outermost, in this region here, out here, we have the neutrons. In the energy levels, in the energy levels we have electrons. In the energy levels we have electrons. So as you can see, the nucleus contains protons and neutrons, and electrons are out here for helium. So why is that important? Atoms are made up of energy levels. So during chemical bonding, we use the electrons in the outermost energy level. So if you don't know the outermost energy level, then this becomes very difficult. The electrons are negatively charged, protons are positively charged, while neutrons are electrically neutral. Very important to note. The noble gases are chemically inert, since their outermost energy levels are completely filled with the maximum possible number of electrons. It means that this here, they don't react, because helium does not react because it is stable. The electron configuration is already filled up. Neon does not react because it is already filled up, therefore it is stable. Argon does not react because it is already stable. That's what we are given here. Thus, noble gases have either a stable duplet is 2, like helium, and a stable or an octet configuration, which is 2.8 or 2.88, as in neon and argon respectively. Other atoms are unstable, mark that. The rest, which does not have the electron configuration of this, they are unstable. If they are unstable, they must react for them to become stable. So during the reaction, they will either lose electrons or gain electrons. So other atoms are unstable because the outermost energy level, mark that, because the outermost energy levels are not yet completely filled with the maximum possible number of electrons. Why do they react? Because the outermost energy levels are not yet filled up completely with the maximum number of electrons. That's why they react. Therefore, to attain the stability of the duplet or the octet, to attain that, what will happen? Such atoms either lose electrons, or gain electrons, or share electrons. So they will either lose, gain, or share. Very important. Now we are narrowing down to what we were supposed to do, bonding. If you don't have what I'm saying, then bonding becomes difficult. So don't jump into bonding when you don't have this basic information. It is the act of losing or gaining or sharing valence electrons that leads. Are you getting that? That leads to what? To chemical bonds. So if you don't know which element loses electrons, which one gains, why should the others share, then it becomes difficult for you to master this. So it is because of losing electrons, gaining electrons, or sharing valence electrons. Valence electrons, these are the electrons in the outermost energy level. Valence electrons is the electrons found in the outermost energy level. Once you have written the electron configuration, the electrons which are outside the outermost energy level are the ones that are responsible for chemical bonding, not the inner energy levels. When atoms gain or lose valence electrons, they become charged, forming anions and cations respectively. That's not very important. Now, there is a note here which I consider very, very important. During bonding, during chemical bonding, only electrons in the outermost energy levels are involved in bonding. I don't know how I can put it in other words, but I hope you have understood that electrons in the outermost energy levels, they are the only one involved in bonding, not any other outermost energy levels only. I want to bring you back to this periodic table again. Let us look at this periodic table. So when these atoms are forming bonds, we consider the outermost energy levels. Here we have 1, 2, 3, 4 energy levels. Therefore, the outermost with the 2 electrons, it is what will be lost or gained, depending on the element. Potassium here, it has 1 electron in the outermost energy levels. It has how many energy levels? 1, 2, 3, 4. The outermost is the one that we consider. Oxygen has 6 electrons in the outermost energy level. So this is what we call the outermost energy level. For argon has 2, 8, 8. It has 3 energy levels, and the outermost energy levels contains 8 electrons. Therefore, it is maximum. It will not react. It will not lose. It will not gain anything. So I hope you have understood the outermost energy levels. They are the one that are involved, that are used during chemical bonding, the outermost energy level. So you must write the electron configuration for the elements involved, and then see whether they will gain, they will lose, or they will share. Very good. Types of bonds. There are 3 main types of chemical bonds. There are 3. We have 3 main. There could be others, but we are talking about main. We have hydrogen bonds, we have other bonds, but the major bonds, we have 3 of them. That is the ionic bonds, covalent bond, and the metallic bond. So you could be worried, where is dative bonding? Where is the coordinate is called? So coordinate is a type of covalent, therefore we don't include it. It is not a type. We have only 3 major, that is ionic bonds, ionic bonding, covalent bonding, and a metallic bonding. Those are the major bonds that we have. So ionic, we will start with ionic bonding. Ionic bond is also called electrovalent bonds or bonding. Ionic bonding is also called electrovalent bond. Why is it called electrovalent? Because here we have a complete transfer of valence electrons from one atom to another. So the meaning of ionic bond means, so what is ionic bonding? Is a bond formed due to complete transfer of electrons from one atom to another, resulting into 2 positively charged ions. So one loses electrons and another one gains the same electron that was lost. So they form a mutual electroforce, and they combine and they stick to each other. So another very important information I want you to have is this. So how will you know that this one is an ionic bond, this one is covalent, or this one is... So the ionic bond is formed due to complete transfer of electrons from one atom to another, and mainly, now this is where I want you to mark this, and mainly between metals and non-metal. That's why I wanted you to know what's a metal and a non-metal. For example, when we have sodium chloride, if I ask you what is the bond between sodium chloride is a salt. The bond between them is ionic. Why? Sodium is a metal, chlorine is a non-metal. What is the bond between magnesium oxide? What is the bond between magnesium oxide? Magnesium is a metal, oxygen is a non-metal, therefore the bond is ionic. So that's why it is important to note. Therefore, magnesium transfers, remember, here, the electron configuration of oxygen is 2 to 6. Fine. Magnesium is 2 to 8 to 2. So see this. Magnesium has 2 electrons and it is unstable, so it will lose the 2 electrons. The 2 electrons are needed by oxygen for it to be stable. So oxygen takes these 2 electrons. So these electrons are transferred to oxygen directly. All of them are transferred so that oxygen now becomes stable by 8, and this one becomes stable by losing 2. So both of them become stable like that. I hope now you understand what we are doing here. This occurs in the bid of both atoms to acquire stable noble gas configuration. One atom loses all its valence electrons, thus forming a cation, positively charged ion. The other atom gains all the lost valence electrons, forming an ion, negatively ion. You have seen I have already given an example of magnesium and oxygen. Magnesium loses all the valence electrons, which are 2, and the 2 valence electrons lost from magnesium are regained by oxygen immediately. So oxygen forms a negatively charged ion, magnesium forms a positively charged ion. That is what we call ionic bonding. The cation and the anion are positively charged and thus develop a mutual force of attraction between them, which is an ionic bond, electrovalent. Because it's negative, positive, they attract each other. Like terms, like they call in physics, they say like charges attract, and unlike charges attract, like charges repel. So because this one is negative and positive, they attract one another and they form a mutual force of attraction which brings them together, forming a bond, and the bond is called ionic. So compounds formed due to ionic bonding are called ionic compounds. Very, very important to remember that ions like sodium chloride, ions like magnesium chloride, zinc chloride, they are called ionic bond because ionic compounds, because they in between them they have ionic bonds. The exception is here. Aluminum chloride, that's where I want you to get. Aluminium is written like this, aluminium chloride. Aluminium chloride is written like that. So my question to you is this. Is aluminium, what kind of bond that is between aluminium? From a glance, you can look at it and then you tell me that it is a covalent, it is an ionic bond. Because this one is a metal, aluminium is a metal, and chlorine is an metal, therefore it is ionic bond. So, with an exception of aluminium chloride is a molecule. Therefore, you should know that aluminium chloride contains dative bonding. Therefore, you leave it out. That's why I've given you except aluminium chloride does not fall under the category of zinc chloride, magnesium chloride. No, this one is very different and very unique, very important. So diagram, we can represent what sodium in terms of the diagram. For ionic bonding, sodium atom has an electron configuration of 281. Chlorine atom has an electron configuration of 287. Chlorine needs 1 to be stable. Magnesium, sodium needs 7, but it will lose 1. So sodium will lose 1, and the 1 lost electron will be gained by chlorine to be stable. So now to the right side, this is the left side, this one is the left side. On the right side, here we will have sodium has lost 1 electron and it becomes positively charged. Chlorine gains 1 and it becomes negatively charged. You can see here it becomes negatively charged. So this is how you represent when you are asked using dots and a cross, represent the diagram for the bonding of sodium chloride. This is the expectation. This is how you are supposed to draw them. So other ionic compounds which will do the same, so potassium fluoride, magnesium iodide, those are there, aluminium trioxide. So I have given also the dot and the cross diagram for ionic compounds such as potassium iodide. Potassium is atomic number 19, so electron configuration 2881. So it will lose 1. The lost 1 electron will be gained by fluorine to have 28. So this is how you represent. Now, what is the difference? Potassium here has lost the outermost energy levels. It has remained with 1, 2, 3 electron energy levels. Fluorine has gained 1 electron from here. We use X dot to differentiate the electrons of fluorine and the electrons of that is gained from potassium. So that's why you see dots and X are the same, because X represents the electron which has been gained, and that is what we call potassium fluoride. Now, when an element loses an electron, it becomes positively charged. When an element gains electrons, it becomes negatively charged. So magnesium oxide also, so you can see this, and then practice. We can have magnesium. So the one I want you to draw, you draw, and you can WhatsApp. My number is also there. You can draw the aluminium oxide and send to WhatsApp so that I can see what you have done. Aluminium 3 oxide. Try to draw it. Draw the dot, and using the dot. The question is using dot and cross diagram. Draw the bonding of aluminium chloride, aluminium oxide. So you will try that. So let me take you through covalent bonds and the coordinate bond, because coordinate bond or rotative bond is a sister to covalent bond. Now, what is the definition of covalent bonding? What is a covalent bond? What is a covalent bond? A covalent bond refers to a bond formed when two atoms of the same or different elements share. That's where you need to understand. Now here there is no complete transfer of electrons. Here it is sharing of electrons. I said complete transfer is between a metal and a non-metal. But for covalent bonding, it is a bond which occurs between non-metals. Non-metals, they react by gaining electrons. So none of them, the non-metals which is going to give out electrons. Therefore, both of them, they will share the electrons to become stable. Refers to a bond formed when two atoms of the same or different elements share electrons to become stable. Covalent bonds are usually formed by the association of non-metals. Very important. Now, imagine you don't know what is a non-metal. You don't know examples of non-metals. How will you tell that this one is a covalent bond? Formation of covalent bond between atoms result to the formation of a molecule. Result in the formation of a molecule. In Form 1, you must have defined what a molecule is. But if you have forgotten, a molecule is a group of atoms of the same or different elements that are held together by strong covalent bonds. That is a writer or a simple definition of a molecule. When two atoms of oxygen atoms combine, they form a molecule. So oxygen, the one you see we write in a periodic table like this, oxygen, this one is an atom. So oxygen plus another oxygen, it forms what? It forms an oxygen, is a molecule. This oxygen is called a molecule, and these ones are atoms. So an atom plus an atom, it forms a molecule. But now look at this oxygen here. This oxygen has a valence of 2 electron conversion of 2,6. This one also have a 2,6. Which one will give electrons? None of them will give electrons. Therefore, they will share to form this molecule. They will share the electrons to form this molecule. So most gases are examples of molecules. Very correct. That most gases, oxygen is a gas, ammonia is a gas, nitrogen is a gas, chlorine is a gas, carbon 4 oxide is a gas, and so many other gases are what? Are molecules. Therefore, they form covalent bonding. They form covalent bonding. So when you are asked, what is the bond between this? What is the bond between this compound? You don't have to think twice. Nitrogen is an non-metal. Hydrogen is an non-metal. Then therefore the bond is covalent. Did you hear that? Yes, you have heard that. That chlorine is an non-metal. An non-metal these are atoms of chlorine. So this is chlorine. This is chlorine. Chlorine plus another atom of chlorine plus another atom of chlorine that gives us chlorine gas. So how do they combine? This is an animetal and an animetal combining together to form chlorine, to form a molecule. The bond is covalent. So it is important that covalent bonds, these are bonds between non-metals, except, I want to give you the exception. Now, I've given you that carbon dioxide is a covalent bonding, which is very correct. But what about carbon dioxide? What about carbon dioxide? Carbon dioxide will undergo dative bonding. So, carbon dioxide, except with an exception of carbon dioxide, with an exception of aluminium chloride, these two, they undergo dative bonding. This one, they undergo what? Dative bonding. And you should know what is dative bonding as we are going to define. It is a type of covalent bond. So they will share electrons. At the end, another one atom will provide the electrons to be the pair to be shared. So we will talk about that. So with an exception of this, the rest of the nanometals, they will form covalent bonds. Nanometals will form covalent bond, but CO, it is a dative bond. It will end with the dative bonding. Formation of a covalent bond. Covalent bonding is brought about by the fact that the electropositive and electronegative of the elements involved are very close. For this reason, none of the atoms can completely lose its valence electrons to the next atom. That is very true. The nanometals are not willing to lose electrons. They want to gain. So therefore, none of them is willing to give electrons. For this reason, both atoms donate electrons, which are then shared between them. For example, in chlorine molecule, two chloride atoms combine for chlorine molecule. Both atoms thus gain a stable noble gas duplet octet configuration. There's a note here that a single covalent bond is represented in a dot or cross X diagrams using two dots. So when you see two dots or two crosses, it means that that's a single covalent bond. A dot and a cross or a single line like this between two atoms involved in the bond means a single covalent bond. Thus, a single covalent bond like in chlorine can be represented as chlorine dash chlorine. So this is a single, single dash you are seeing here that I have highlighted with red is a single covalent bond, 2 electrons. A double covalent bond like in oxygen can be represented by 2 dashes like that, and this, it represents 4 electrons, 2, 2. While a triple covalent bond like in nitrogen is represented as that. So I am sure when we are going to draw these things, you are going to understand even better because I'm going to draw them. Then the last thing I want to talk about is the coordinate bond, which we also call dative bonding. Dative bond. Coordinate bond is a dative bond. But once you have understood a covalent bond, then dative bond is very easy because it is just a sister to covalent bonding. So what is dative bonding or coordinate? It refers to the type of covalent bond. You hear that? It is a type of covalent bond. So if it is a type of covalent bond, first they will share electrons. They will share up to a point when the other atom fails to have enough electrons to be shared. Therefore, another one now which contains more electrons will just donate the 2 electrons to be shared. So this is referred to a type of covalent bond in which the shared pair of electrons, forming the bond is contributed by only one. That's where the thing is contributed by only one of the atoms forming the bonds. Unlike in covalent bond, both atoms, they provide electrons to be shared. But in dative bonding, it is only one atom that will provide a pair of electrons to be shared. So when we will draw this, you will see and understand very well. I know you will understand once we start drawing the dative bonding structures. So another thing I want you to know is the examples of elements or compounds that are form dative bonding. One of them is the ammonium ion. Ammonium ion is written as NH4 then positive. So this is an example of a dative bonding. And I want to explain what it means for ammonium ion to be like this. I want to put this one to be like that, and this one should be the subscript like this. So ammonium ion, when we have a positive sign there, so any compound you see that contains a charge, that contains a positive there up, this positive, always don't think twice. That one will undergo dative bonding. It will go covalent to covalent and then finally dative. So whenever you see a compound with a positive, remember that compound will undergo dative bonding. So that's one of the things you must check. So another thing, so look at that, that's ammonium. We will go and through that. We will draw the structure there. You will see, I will draw all of them. And then another one is hydroxonium ion. Look at this. It has a positive charge. So this is another example of a compound that undergoes dative bonding. So I've told you that look at the compound. Any compound which has a positive charge will undergo dative bonding. I will explain when I will be drawing the structures. When I will be drawing the structures, I want to just give examples. We have more other examples, so I will give you more other examples. We give you more other examples. Further example for dative bonding is carbon 2 and not carbon 4. Carbon 2. So carbon 2 is the only odd one out. This one you have to master that. Carbon 2 will undergo dative bonding. Except carbon 2 and aluminum chloride, which is a dimer. These are the two compounds which will undergo dative bonding, unlike the rest. So this one is an animetal and an animetal. So somebody could imagine that it is going to undergo covalent bonding. No, it will undergo covalent and then finally dative. So carbon 2 oxide, master it like that, that it will undergo so this is pH, this is phosphorus H4, because it has a positive charge, it will also undergo dative bonding. So I've told you these are the examples which you must have in mind. You must have these examples in mind so that you can be able to. So the next bit of I will now take you through how to draw these structures, and I will be explaining more while we are drawing. So I said we want to draw, but before we draw, let us identify. This, I have compounds here, a mixture of covalent bond, ionic bond, and a dative bond. So able to answer kujua which type of bond are between these compounds. Number one is hydrogen. Hydrogen gas. What type of bond that is between here? Hydrogen is an animetal and an animetal, therefore the bond between them is covalent. Potassium fluoride. Potassium fluoride, this is a metal and this is an animetal, therefore it is ionic. Hydrogen fluoride, hii ni nanimetal, ni nanimetal, kwa hivyo ni covalent. Nitrogen is an animetal and an animetal, because it is nitrogen plus nitrogen which forms nitrogen gas. Therefore, it is covalent. Water, oxygen is an animetal, hydrogen is an animetal, therefore the bond is covalent. Magnesium chloride, this is a metal, this is an animetal, therefore ionic bond. Carbon 4 oxide, this is an animetal, oxygen is an animetal, therefore covalent bond. Ammonia gas, this is an animetal, nitrogen is an animetal, hydrogen is an animetal, therefore covalent. Methane, non-metal, covalent. Phosphine, phosphorus number 15, hydrogen number 1, non-metals, both of them, covalent. Carbon 2 oxide, it is the only one that will undergo dative. So it will start by undergoing covalent, then finally finish with dative. Therefore, the final covalent bonding is dative. So carbon 2 is the only difference from the others. Though this is an animetal and this is an animetal, it will not only go covalent bond, but it will finally finish with dative. Therefore, this one is dative bonding. Ushike kwamba carbon 2 oxide will undergo dative unlike carbon 4. And then this is an animetal, so it is covalent. Hydroxonium ion, whenever you see a charge here, ukiona a compound imeandikwa na imewekewa positive charge, then that one is dative or coordinate. Ethine, that one is covalent. Ethanol, covalent. Promethane, non-metals, all of them, therefore covalent. This compound here, because of the charge here, it will undergo dative. Hydroxonium ion, nimeshazungumzia, it will undergo dative bonding. Formation of pH4 positive. So our guide is this charge here, pH4, this charge here. So this one will undergo dative. Aluminium chloride dimer. Sasa, this is another exception. Aluminium, despite the fact that aluminium is a metal, chlorine is an animetal, this one does not undergo ionic. It is X. It doesn't undergo ionic. So, instead, it undergoes covalent and then finally finishes with dative. Therefore, aluminium chloride dimer undergoes dative bonding. I have told you the exceptions. Exception in aluminium chloride dimer, exception in carbon 2 oxide. Carbon 2 oxide is not a covalent but dative. Aluminium chloride, being a metal and an animetal, it doesn't honor the ionic bonding, but it takes the bond of coordinate, that is dative. Magnesium oxide, this is a metal and animetal, therefore this one is ionic. Sodium oxide, ionic. Aluminium 3 oxide, ionic. Bond. So that's how you identify the types of bonds. Next, now I will draw some structures for some of the compounds we have talked about. For example, I will start with hydrogen. How would you draw hydrogen? The structure using dots and a cross. How would you draw? Hydrogen? Hydrogen, we have said hydrogen is atomic number 1, right? So being atomic number 1, the one atom has got one electron, only one electron. So 2 atoms have combined. So therefore it will undergo covalent bonding. Covalent, it looks like this. You draw a circle, you draw another one. Then you put the sign for the chemical symbol for each atom. So this hydrogen and this hydrogen has got only one electron, and this one has got only one electron. So what they do, this hydrogen is not willing to give. This one, neither this one is not willing to give. Kwa hivyo kile ninafanya, hii inakubaliana kwamba wacha nitoe yangu moja na wewe utoe yako moja to share. So they share one like this. So once umechafua pande, we need to see a clear diagram. So you draw a very clean diagram. H, like this, like this. So that is hydrogen gas. This is hydrogen now molecule. This one can also be written as H dash H. This one is also good. Potassium fluoride. Potassium fluoride, this is potassium and this fluorine, so it is ionic. And if it is ionic, then you should know how you draw the structures of ionic bonding. So we will start potassium is K, which is atomic number 19. Fluorine is atomic number 9. So fluorine is atomic number 9. Potassium is atomic. So let us write the electron configuration 2 to 8 to 8 to 1. Potassium. This one is 2 to 7. So naona fluorine inakosa moja ikuwe stable. Pia potassium is going to lose this one, and this one will be transferred to fluorine. So that's what we call ionic. So we draw potassium K. Potassium has got 1, 2 energy level, 3 and 4. Plus fluorine F 1 and 2. So they have electron configuration as, so this one is 2, the innermost energy level is 1, 2, this followed by 8. So this is the structure for potassium, and this is the structure for fluorine. Fluorine, the outermost energy level is 1, 2, 3, 4, 5, 6, 7. Fluorine is only 1. So potassium is 1. So potassium will lose this 1 electron, and it will be taken by fluorine, right? So the energy level, the outermost energy level of potassium itapotea. This one, it again this electron which has been lost from potassium. That is what we call transfer of electron from one element to another. So finally, you withdraw potassium with now 3 energy levels, because it has lost the outermost, that is 2, and then 3. It has lost the outermost energy level. You put the remaining electrons here, and then you draw for fluorine. You need to put this sign here. Because it has lost 1, you put positive here, and then fluorine F. You do the same. It will regain 1, so minus. So this one ilikuwa na 1, 2, 1, 2, 3, 4, 5, 6, 7, 8. 1 2 3 4 5 6 7 8. This one 1 2 1 2 3 4 5 6 7 8. Ex ni yenye making from potassium, and now this one is potassium ion, and this one is fluorine ion, like that. So when they combine now, they form potassium fluoride. Nitrogen is atomic number 7, so 2 to 5. So each has got 5 electrons in the outermost energy level. So since it is an animator kenye watafanya, they will just combine and then share the electrons, because none of them is willing to give electron like that. So this here, the second one has got 1 2 3 4 5 6. This one has got 1 2 3 4 5, not 6 but 5. It has 5 in the outermost energy level. So hakuna yenye iko willing kupeana, so they will share. This one itatoa 1 electron, this one itatoa another one. So if you count the remaining 1 2 3 4 5 6, they are not stable, they continue sharing. Zimepaki tatu 1 2 3 4 5 6 7, bado 1 2 3 4 5 6 7, bado ijakuwa stable because the stability is supposed to be 8 or 2. So it is this one we expect ikuwe 8. Therefore they continue sharing. Pia itatoa moja, hii tena itatoa ingine. So now when you count, these are 4 5, these are 1 2 3 4 5 6 7 8, and then the remaining zenye zimepaki hapa outside, you put them inside here. 1 2, and this one 1 2. Now we have finished everything. So this diagram inafaa kuwa clean as this one, pira uchafu. Hakuna ukiweka uchafu hapo ndani ya madot, it counted as an electron, so that one is wrong. So this one can be written as also as nitrogen this one is as good as this one. So carbon 2 oxide gas, tumesema kwamba it is a dative. So let us look at how dative is it. Kwa nini tunasema hii ni dative na si covalent? But remember we said dative is a type of covalent bond. You always remember that. So tunaandika carbon and then followed by oxygen, like that. So oxygen, carbon. Kumbuka carbon iko na 4 electrons, so 1 2 3 4 out in the outermost energy level. Oxygen iko na 1 2 3 4 5 6. So first, because dative is a type of covalent bond, they will share first, so like this. So oxygen itatoa yake moja, iweke hapa. Carbon itatoa yake. Sawa? Now you count 1 2 3 4 5 6 7. So oxygen itakuwa stable na carbon itakuwa stable. They continue sharing. Sawa? So ukihesabia na oxygen 1 2 3 4 5 6 7 8. Oxygen already iko stable, lakini carbon 1 2 3 4 5 6 iko stable. Haiko stable. Carbon haiko stable, lakini oxygen already imekuwa stable. What happens now if we continue sharing for carbon ikuwe stable hapa ndani, tuna realize kwamba oxygen inaenda kuwa na more than 8, which is wrong. This is the time now oxygen inasema let me take my 2 electrons from outside here, niweke hapa ndani 1 2. So unaona imeleta zake zote mbili. So let us put the remaining for oxygen, this one hapa ndani 1 2, and then carbon 1 2. So if you count for each of them, you realize that it is step 1 2 3 4 5 6 7 8. 1 2 3 4 5 6 7 8. So inakuwa additive kwa sababu oxygen inapeana electrons zake hapa ndani mbili to be shared, a pair of electrons. So this is how we draw it. You can as well draw it as O C, and then this way. Here 1 2, here 1 2. This one is also allowed. Let us look at hydroxonium ion. Hydroxonium ion, wakati wote unaona hii positive charge hapa, inamaanisha one of the hydrogen inside here is empty. If the positive ni moja, one hydrogen is empty. Ukiona two positive 2 charge, it means 2 hydrogen are empty. So one hydrogen is empty, we draw. Nikasema kwamba ile ambayo ni moja, hapa tuko na oxygen moja, atom moja na hydrogen atom 3. Kwa hivyo ile iko na moja ndio inakuwa the center, alafu inakuwa surrounded na hizo zingine. So oxygen will be at the center, and then itasungukwa na 3 hydrogens. 1 2 3. Just write the hydrogen. Ni kwa nini nimeweka moja, one hydrogen is empty, ndio maana iko positive. So it means this one is empty. It doesn't have any electron. It's empty. But this one has got 1 electron. This one has got 1 electron. Oxygen peke yake kuna electron zake 6. Huko tukiandika oxygen ni 2 to 6. Kwa hivyo iko na 6 outermost electrons. Iko na 1, 2, 3, 4, 5, 6. So they will share like this. Ile yenye iko na yake itashare. Hydrogen haitapeana yake ati bure. Itashare. So itasema wacha niweke yangu moja hapa ndani, na wewe oxygen uleta yako ili tushare. So this one will bring 1. So inatoka hapa nje, alafu na oxygen pia italeta yake. Huyu kwa sababu ako na yake ataleta hapa, na oxygen ataongeza ingine ili wafanye kushare. Hiyo inaitwa covalent bonding. Sasa inafika mahali nikihesabia hydrogen hii iko stable, hii hydrogen iko stable. Oxygen nikiweka hizi zake hapa ndani 1 2 zenye zimepaki hapa nje 1 2, nikiweka hapa ndani hizi zote, you realize that oxygen is already stable. So 1 2 3, oxygen iko stable na hydrogen iko stable, hizi zenye zilikuwa na electron. But this one is empty, haina chochote, so iko unstable. Now this is the time dative inaokaa. Hii oxygen inasema wacha nilete hizi zangu zote tusiweke hapa ndani, ndio hata wewe ukuwe stable, hata mimi nitakuwa stable. So inachukua hizi mbili inaweka hapo ndani na inakuwa stable. Kwa hivyo zile mbili zenye zilikuwa hapa ndani inawekwa 1 2. Now if you count for each atom, you realize that it is stable. This hydrogen is stable, this one is stable, oxygen iko stable 1 2 3 4 5 6 7 8. So once umemaliza hivyo, you put the charge in outside like this. Kwa hivyo hii ni uchafu, kuna uchafu, kuna huu uchafu, kuna huu uchafu. We don't want to see this, so you draw it a clean one. Now after doing that, you draw a clean one on the other side. So this is now the clean diagram that we want to see, very clean one like this, and then you get your marks. Now look at this compound here. Do you think it is dative, covalent, or ionic? It is dative. Why? Look at it. It has a charge of 2. And this charge of 2, it means that 2 hydrogen atoms are empty. That is the key word. It means that 2 hydrogen atoms inside here are empty. Positive charge means that an electron was lost. Hapa element yenye inaweza poteza electron ni hydrogen, sio oxygen. Kwa hivyo hydrogen ndio iko empty. It is empty. So now we draw. Hydrogen ni 4, oxygen ni 1. So tunaweka oxygen at the center. Then tuna surround with 4 hydrogen atoms because there are 4 of them. Like that. We know that hydrogen iko na 1, kuna moja iko empty, kuna zingine zenye ziko, let me put this one ikiwa empty. So 2 of them are empty and 2 have electrons. So hii iko na electron yake, hii iko na electron yake, but this one is empty. This one is empty. Oxygen iko na electron. Now what will happen is that they will start sharing covalently. So hii hydrogen, si unaona iko na yake moja, itaweka hapa. Oxygen pia itatoa yake. Hii yenye iko na yake, hydrogen hii italeta yake hapa. Oxygen pia atasema wacha nilete yangu to share. Sawa? Lakini sasa inafika a point, this hydrogen imeandika tu hapa na hii 1 they are empty. Hii na hii they are completely empty. They don't have anything. So this is the time now oxygen kwa sababu iko generous inasema ndugu yangu, because I can see that you are empty na mimi niko na excess hapa 2 na kuna excess hapa, what I will do, I will just give you mine so that we can share. So hii inachukua hizi zake zikiwa ina xx inaleta hapa 1 inaweka hapa, na inachukua hii pair nyingine inaweka hapa So unaona ukihesabia each of them unapata iko complete na iko stable. So this is what we call now dative. That is when dative comes in. When one atom provides a pair of electrons to be shared. So once umechafua hivi now, we will not mark that. What we want to mark is a clean diagram. So you come here and draw now a very clean diagram like this. Oxygen. Draw the outermost energy level in oxygen. Surround this one with the outermost energy level. Then 1 hydrogen, another hydrogen, another hydrogen, another hydrogen. This one is empty. This one is empty. This one has something. This one has an electron. So we have said this one will provide 1, oxygen will provide 1. Will provide 1, oxygen will provide. But this one is empty. Oxygen ndio itapeana zake 2. Oxygen ndio itapeana zake 2. Once umemaliza hivyo, unachora hivi, alafu unaweka ile charge ilikuwa hapa ni 2 positive, na utakuwa umemaliza maneno namna hiyo. Now kuna mingi nimeacha, please can you try and draw this. You can as well draw the ones I left behind here. Kuna hii ambayo ina behave kama ammonia. Hii ni ammonia, zitachoreka the same. Kuna carbon 4. So you can try and draw where you have a challenge, you can always contact for help. Thank you.